Welcome, and today we will be seeing three levels of integration problems. We will have easy, medium, and hard level problems, and let's see how these problems pose how much difficulty to us. So, do try it on your own for every problem. We will begin with the easy problem, we will then go to the medium, and then to the hard problem. So, obviously, it's an ascending order of difficulty, and anyone who has done quite a bit of definite integration should be able to do these. So if you're preparing for exams like JEE and ISI, this is also a very good practice for you. But if you're already in university level, so this is also again going to be just a refresher for you. Nevertheless, these are fun problems, and I'm sure you're going to learn a thing or two. Let's move on to our easy problem. So easy problem is 0 to 1 x cube upon x minus 2 dx, right? Now, in problems of this kind, we usually, since this is just a polynomial upon polynomial type, right? So we try to use partial fractions usually, but it's a definite integral, and we understand that this function is continuous because this does not blow up between 0 to 1, right? It's just negative in 0 to 1 because the denominator is negative. That much we can understand. We will start off with just simply substituting x minus 2 as t. This is because I do not want the denominator to be something like that. I want the denominator to be a single variable like t or u, and I want the numerator in the form of whatever the denominator is so that I can expand the numerator. That is my whole idea, right? So if I put x minus 2 as t, this implies that x is equals to t plus 2. And this would give me dx is equals to dt. So remember this because whenever you have this polynomial upon polynomial problems, you should do this. This would simply reduce. So first of all, what are going to be the new limits? To find out the new limits of integration, the previous variable was x and the new variable is t. Put the values of the previous variable x here. So for lower limit 0, if I put 0 here, t becomes minus 2. And for 1, it simply becomes minus 1. And x becomes t plus 2 whole cube. So this becomes t plus 2 whole cube upon t dt. Correct? And next, after this, we are going to see how if this integral actually converges or not. We're going to see that obviously. So that is the whole problem, whole part of this problem basically is to see if the regular calculations that we do, because this seems so much integrable because it does not blow up and stuff like that. But at the end, we will be left with a surprising decision as well. So you will see. So anyway, minus 2 to minus 1. So you can simply expand it like t cube plus 2 cube, which is 8, and then simply write 3 into t into 2 times t plus 2, right? And this is divided by t dt. Now, if I were to simplify it further, I would simply get minus 2 to minus 1. So t cube by t is going to be t square. Then 8 by this 8 by t term, that is something which is going to trouble us. Okay, 8 by t, and then we have 3t square into 2, which is 6t square by t, which is 60. And then we simply have 3 into 2 into 2, which is 12t by t, which is 12 dt. We understand that the rest of the terms can be integrated, but what about the 8 by t term? Because the antiderivative of 1 by t is ln of t. But the limits of t are from minus 1, minus 2 to minus 1. So this is why my question to you, so there would be a question in every problem from my side. My question to you is obviously this, and this can be integrated and you will get the final answer. But for the 8 by t term, so let us do it here. We will get 8 ln t, and the limits would be from minus 2 to minus 1. So first assumption should be that ln t is not defined for negative numbers, therefore this integral does not converge because this does not give you a real answer. And another assumption could be that, okay, fine. If I apply the properties of log, like writing it anyway, like this, I see that this simply becomes 8 into ln of 1 by 2 because minus 1 divided by minus 2 is 1 by 2. So should I take this assumption, this answer, or should I just take not convergent? So what do you think is the correct answer? Let me know in the comment section, and I will try to uh, expose the correct answer as well in the comments. But this is a question to the audience. Okay. Now let's go to the next problem. This one was easy only because We only have a simple question at hand, that is this valid or not, and the integration was pretty simple. After this, we are going to have some pretty good level problems. Let's go to the medium one. In the medium level problem, we have 0 to infinity ln of x divided by x squared plus 2x plus 4 dx. Now, this integral ln of x, and then we have a polynomial, a quadratic polynomial to be precise. There is a certain way of solving this kind of problems, which is not going to be very obvious at the first. So if you try substituting things here like ln x equals to t, you might make things worse than they were before. So there's a particular technique you need to use here. So I'm going to introduce you to that technique to find out the value of this kind of integrals. First of all, look at the constant term in the quadratic. It's 4. So if you have a quadratic equation like this, look at the constant term and substitute y is equals to 4 upon x. This is your new variable y. The limits we can already understand. The limits are going to be infinity to 0 for 0 and infinity respectively. And we can make the transformations now, because we understand that x is equals to 4 by y and that dx is equals to minus 4 by y squared dy, correct? This would mean that we will have infinity to 0. Ln of x is going to be ln of 4 minus ln of y. And now this is going to be, x square is going to be 16 by y square. 2x is going to be 8 by y. And then we have a simply 4. And then dy is nothing but minus 4, dx is nothing but minus 4 by y square dy. Put the minus and interchange the limits, so it becomes 0 to infinity. And then you have a 4 here, cancel off the 4s and multiply it by y square. So I think you simply get ln 4 minus ln of y divided by, and here you have y square plus 2y plus 4 dy. And you can separate this into two parts. So you can simply write this first integral as ln of 4, 0 to infinity dy by y square plus 2y plus 4. And then you can write again 0 to infinity ln of y by y square plus 2y plus 4. But if you remember, this is the integral we started with. So if this integral is I, the next integral is I as well. From the equation, we get I equals to this minus I. So 2I should be equals to this integral, solving for I. So therefore, our actual answer should be I equals to ln of 4 by 2, 0 to infinity dy divided by y square plus 2y plus 4. Now this is simple because this can be written as a perfect square, which is ln of 4 by 2, 0 to infinity, and you can simply write this as y plus 1 whole square, and then there's 3, which you can write as root 3 whole square. Okay. This is in the form of arctangent. You can do this, and you know that arctangent of infinity is pi by 2. Apply the formula, and you understand that ln of 4 is nothing but 2 ln 2. So doing all this, final answer 2 ln 2 by 2, which is ln 2 by root 3 into pi by 2. So pi ln 2 by 2 root 3. This is going to be your answer if I'm not mistaken, and if I've not committed any silly mistakes. But the technique remains the same. You have to use the substitution y equals to 4 upon x. So the 4 comes from the constant term. If it was 8, I would have used 8 by x. Correct? So let's move on to the next one. This was a pretty good problem, right? And this substitution, if you do not know the substitution, it might be very hard to do this problem. So this is a hard section of this video, but yeah, this is not going to be insanely hard, because in this video we're not trying to do problems or bring up problems that you cannot actually do. We want to have you do the problems that you can attempt and maybe even succeed in doing them, right? We're trying to limit them to high school level. So obviously here we need to understand something here. 1 by 2024 times 2024. This is our entire question. Now, in order to do this problem, we can actually try and do some manipulations here, because you see the tan inverse x function, and there is an x function here. There are multiple ways to go about this. One of the ways I can show you. So let us try doing this. Let us define a function like this. F of a is equals to, let us say we have this 1 by 2024 to 2024, and then you have this tan inverse of ax by x dx. If you now were to differentiate tan inverse x, which means if you differentiate both sides using Feynman's trick, so this would give you simply 1 by 2024 to 2024, and differentiating with respect to a means x is treated as a constant here. We're doing partial differentiation, right? So this would mean that we would simply have x times 1 plus a square x square, and then x is the coefficient because we are differentiating with respect to a. So according to chain rule, we should have a x here as well, and this would cancel off, correct? But this is our first attempt at this problem, so this naturally comes to mind, right? Now, if we were to do this, you would notice that ultimately, if you complete this integral, you will still be left with the same integral as before, because you are not really helping things, because if you do this, you will get back the same thing after integrating. So whatever you get after you integrate both sides, you will still get f of a is equals to 1 by 2024 to 2024, and then you would simply get tan inverse of ax upon x dx. So this does not really help, but my purpose for showing this method was to just signify that maybe we can parameterize something else. So now let us consider a separate thing like g of u, and let us try to do something here. So if I say this is 1 by u to u tan inverse x upon x dx. Now try making the substitution x equals to 1 by y here. So if I make the substitution x equals to 1 by y, what happens? This simply gives me dx is equals to minus dy by y square, correct? So let us try and put that value in. We will get that g of u is then equals to x is 1 by y, so the limits are reversed, so it's basically u to 1 by u now. And tan inverse of 1 by y is nothing but cot inverse of y. Then x is nothing but y inverse, and then dx is nothing but minus dy by y square. So it's minus dy upon y square, correct? Y squared times y inverse is nothing but y. So, and the minus gets in. So you simply get this is equals to 1 by u to u cot inverse u, cot inverse x by x. You can simply write it like this because the y and x are interchangeable since it's a definite integration. Now, these are the two representations of g of u. But we do understand that since if we add these two representations, we get 2 times g of u is equals to 1 by u to u tan inverse x plus cot inverse x by x dx. But we do note that tan inverse x plus cot inverse x is pi by 2, which means this would give me pi by 2. Then 1 by u to u dx by x. And if you do this, ln of u minus ln u, which is 2 ln u, you would get the answer as pi ln of u. Therefore, the answer to our actual question is pi ln of 2024. So that should be all for the video. I hope you like the problems. I hope you like how we approach them, how we tried two different ways for every problem. So there are obviously harder integration problems, harder mathematical problems, but we cannot approach them before knowing the previous. So that is why this is my attempt of trying to get through the ladder step by step. So if you like this video, do like and let me know your thoughts in the comment section. Thank you.